now this is recording. RTI
International
Center for
Forensic
Science
presents
Just Science.
Welcome to Just Science, a podcast for forensic science professionals and anyone who is interested in learning more about how real crime laboratories work. In episode 8 of our drug season, Just Science discusses research in the area of e-cigarettes with Dr. Michelle Peace. Vaping, the act of inhaling vapor from an e-liquid through a vaporizer, or also known as an e-cigarette, has gained popularity in recent years. The first half of the episode was recorded over a year ago. During the second half, Dr. Peace will give us an update on where her research stands today. This season is funded by the National Institute of Justice's Forensic Technology Center of Excellence. Here's your host, Dr. John Morgan.
And welcome to Just Science, the podcast for forensic science professionals. I am John Morgan, your host with Forensic Technology Center of Excellence. Michelle has a Master of Forensic Science from George Washington University, a PhD from VCU. She actually served as the lab manager at Kroll Labs, which is a private forensic toxicology laboratory, and returned to VCU in 2007 as the associate chair of the Department of Forensic Science and has really worked hard to develop their leading undergraduate program. What I want to spend most of the time talking to you about is the work that you've done on looking at vaping. And I think it's funny. I mean, I remember the first time, sometime last year, that I got annoyed with somebody. I don't know whether I was in a restaurant or the mall or something like that. And I was like, what is that person smoking right in the middle of the restaurant?
Right.
And and I was like, but I don't smell smoke. And I realized that they were vaping. So I guess you all noticed that as well. Isn't that right?
Yeah. I love interacting with students because they can often be the source of some really great ideas. Just not that long ago, and I want to say maybe 4 or 5 years ago, an undergrad student had studied abroad, had come home. You know, she was just dropping into my office to check in and say, hey, I missed you guys, but I had this really great experience. While we were debriefing, she brought up the fact that while she was in Europe, hey, there are these things called electronic cigarettes. So what was interesting was that at the time, electronic cigarettes were very popular, had really taken off widespread in Europe. And they were only beginning to take hold here in the United States. And so when you look at kind of like the marketing for electronic cigarettes and its spread worldwide, that's exactly what had happened, is that, you know, it had spread from China into like Australia and to Europe and had taken on strongly there and then hit the United States strongly next. So she was at that interface. So she comes into my office and she says, hey, I think it'd be really cool to work on electronic cigarettes. And I said, well, this is forensic science, so how would that be relevant? So we chatted for about an hour, and she was a smoker. So she was really interested in it from this perspective of another delivery mechanism for nicotine. So she thought that this was just the coolest thing because of this. It's somewhere between perception and not scientifically validated yet, right? I mean, as a country, we're still struggling with this in terms of, are electronic cigarettes healthy? Nonetheless, the perception is that by the public that they probably are a healthier option to consume nicotine than a traditional cigarette. And I'm not going to disagree with that. I'm also not going to say that they are a quote-unquote healthy option. So she was very interested in that kind of research, and I kept saying, well, why would I be interested in that? And so really out of that conversation, I said, whoa, this could potentially be something that as a forensic toxicologist, as a forensic scientist, that might hit either Europe and or the United States pretty strongly, to have a device that is unregulated, easy to get, easy for children to get, that they're going to be looking for ways to actually consume illicit substances in a manner that they can get it and that is socially acceptable to see people vaping in public at the time, right? I mean, we have to kind of reverse to where we were 4 or 5 years ago. So that was the generation of the project. And so I kicked it around and talked to a handful of people because 4 or 5 years ago, I had never even seen an electronic cigarette. It took me, I don't know, maybe 6 or 9 months to kind of get my head around what are these things, what are they doing, how prevalent are they, and just kind of paying attention to what was going on. And then I met with a handful of my collaborators here at VCU. And, we've got a long-standing relationship with people from other departments. And so I said, hey, there's an NIJ cycle coming up for research. Why don't we put in for it?
How did you just kind of scope what you were going to call vaping, and how you're just going to look at them as delivery devices for drugs, whether it be nicotine or something else?
Yeah, so I talked to a lot of vapors. I went to a lot of shops. So you guys are in North Carolina, right? And we're in Richmond, and this is the heart of tobacco country, so to speak. It's not a far stretch to say, hey, there's some kind of tobacco shop on every other corner. So we visited a lot of vape shops, in those early days, and we talked to 4 years ago, it was just beginning to take hold in terms of popularity. So the vape shops were pretty quick to stand themselves up. Some of the really early concerns, so there's a couple of different kinds of systems, and I think the first one we need to dispel, and when I talk to law enforcement, one of the first things I talk to them about is that an electronic cigarette, maybe the one that we would be most concerned about from a forensic science or criminal justice perspective, are not the closed system ones, the ones that actually look like a cigarette. Those are closed systems, difficult to impossible to change or modify, right? It's a closed system. So the ones that we knew that we were going to have to deal with from a research perspective were the open systems. The open systems mean that you can actually take them apart and refill them. And there are a couple of different ways that users could do that. There is one method that they call it a polyfill. That's just their word for there's a sponge in there that they soak with the liquid. It's an e-liquid. So that's one method. The other system are these tanks that holds anywhere from 2 to 7 mils of an e-liquid. And so those were the ones we knew that we had to take a look at, because those are the ones that, of course, if you're going to adulterate an e-liquid, you got to be able to get it into the e-cigarette somehow or another. So we knew we had to look at the open ones. And then once we realized we knew we had to look at these open devices, then we realized, well, there were multiple generations of the cigarette itself, the e-cig itself. And some of them are very simple. Some of them become quite complex. The most recent generations of the e-cig have a lot of ways that they can be modified by the user, and the user thinks that they're changing their vaping experience by selecting different options and making their own devices. So when we looked at the open systems, there were two things that came out of that users can either modify the e-cig itself, the hardware itself, to change their vaping experience, and by changing their vaping experience, it can be as simple as changing the cloud formation, or what they think is actually changing the concentration of drug in the cloud. That's just by changing the hardware. The other way is by changing the e-liquid itself. So then we realized we had to decide on a model, right? So when we applied for the grant, we met with a lot of vapors and visited a lot of vape shops. So we knew we just had to pick one, and knowing that when we picked one, it was going to be outdated in 6 months, just like a computer they buy. They get so outdated so quickly. And so even though the one that we selected is no longer a high-end model or one of the most popular models now, it was a really relevant and popular model, and it still enables us to do relevant research because, again, it can be modified. So we can make it do what current generations are doing.
Do you have anything in terms of, your experience and experimentation on these devices that leads you to believe that there's a great deal of difference in all the different models and the development of these systems? I mean, are people fooling themselves, or is there something real about the changes in the different models?
Yeah, it's a little bit of both. So one of the things that we knew that we had to do with the grant, and we wrote it in, is that we have to develop this kind of like a baseline understanding of the devices. So if we just put nicotine into the device and we change the hardware of the device like the user is going to change it, is it really changing the concentration of drug in the cloud? So that was our first question. So we have spent a lot of time just developing a baseline understanding of the device. and frankly, an analytical scheme that we can apply to anything. We had to develop a trap to capture the cloud and make sure that that worked, and develop analytical methods that were going to allow us to analyze essentially the cloud or the e-liquid or the device so that we could capture this data no matter how we manipulated things. We've spent a lot of time developing that baseline, and there are some things that when the users say that they're changing things that might be more myth than reality, and that there are some things that the users are doing that actually do impact the drug delivery. We're still a little bit early in completely understanding that, and so we've submitted for another grant with the NIJ so that we continue the study, because we think we're really at the front end of really understanding this deeply.
Is nicotine a reasonable model for most of the drugs of abuse that people are using inside these devices?
Yes, in terms of a model of a drug of abuse, we think it's reasonable from the perspective of it's going to be the most common drug that's in the e-liquid. Once we developed the model of does our trap work, do our analytical procedures work, and when we change things with nicotine, are we seeing a relationship? We think it's reasonable from developing the model from that perspective. In terms of how it will apply to other drugs of abuse, once we know that the analytical scheme works and our trap works, then we'll be able to put most anything into the devices, we think, and see, is it reasonable for a user to say that they are getting a hit off of X drug because they put it into the E-Cig? And because we've built the model and we know the model works, then we can test it with any drug of abuse.
So what is an e-liquid really? I mean, what are these e-liquids actually made of?
So the e-liquids, just a couple of pretty fundamental, pretty easy to get components. And so you hear the users say, our PG-VG ratio, our PG-VG ratio. What is that? So PG is propylene glycol and VG is vegetable glycerin. So those are your two main components. And users will mix those in a ratio depending on the kind of experience that they want. The users will say that if they're more interested in the hit than as opposed to cloud formation, then they will swing the ratio in one direction. But we think the most common ratio is just a 50-50 mixture of propylene glycol to vegetable glycerin. That seems to be the most common. And that seems to be the most widely advertised. But you'll see when you go online to vendors that they'll give users an option of do they want 100% PG, 100% VG, or 50-50 mixture. So actually our second manuscript for the grant effort, we actually looked at 27 e-liquid products purchased in the United States. We tried to track down were they all manufactured in the United States, and to the best of our ability, we were able to determine that all of the e-liquids were generated in the United States. So it's the first study where it's a 100% USA-made e-liquid products, because all the previous studies were either a mixture of international versus American or all international e-liquids.
A lot of them are being just formulated in the backs of gas stations, basically, aren't they? I mean, are people just buying these liquids in these premixed formulations and then adulterating them, or are they taking the liquid from basically a nicotine mix and just adulterating that, or is it just all over the park?
It's all over the place. You're right. A lot of folks making e-liquids they just have a little shop set up in their kitchen or their garage, and they take a box of their best products that they have literally just printed off a label and taped it onto the bottle, and they look like they're homemade. You're trusting somebody to make sure, somebody like that who bought high-quality product, that they put the right concentrations of things in, who probably don't have a science degree. And in those kinds of instances, you are kind of throwing caution to the wind. But there are quite a few very legitimate, very serious e-liquid and e-cigarette manufacturers here in the United States. There's a very popular one here in Richmond that VCU has developed a relationship with, a couple of departments who are studying electronic cigarettes. They have a very robust manufacturing process and a very robust QA/QC program. So their product and the quality of their product you can probably trust. A few years ago, when there was a lot of concern about these people who are manufacturing e-liquids in their garages, the industry did try to come together and develop best practices. But, those aren't mandatory. So it was still possible for people to manufacture these. You can go onto large online vendors and purchase the parts. You can just buy a bottle of propylene glycol, vegetable glycerin, and you can get a bottle of nicotine. You want to make it almond flavor, then you go to the grocery store and you buy almond flavoring and you put it in and you mix it up and you've got yourself an e-liquid.
Right,
So,
yeah, and all you need is a nebulizer at that point and you're done, right?
And you're done. And those are actually quite easy to also make.
So I'd like to know more about that aspect of it, because to my mind, this would be very hard to get your mind around because it's been basically an unregulated market, isn't that right? And so there's a lot of kind of homemade garage formulations and devices and that kind of thing. I know that the FDA, I guess, is talking about regulating them more closely now.
Well, one of the things that we saw, and we started this about 2.5 years ago, was monitoring all of the states, because this has been people have been wanting the FDA to stand up and say something, and there have been lots of work groups held by the FDA to pull scientists together worldwide to say, what are these things and what are they doing? What's the data showing us? So that they could develop some kind of regulation. So the FDA had to take some time to kind of figure this out. In the meantime, what wound up happening, the states started standing up their own legislation. For the most part, we saw the legislation saying that people under the age of 18 could not purchase these. They couldn't have access to them because up to this point, a 12-year-old could go into a corner store and purchase the cigarette and the liquid. Until states started regulating these, kids could have access to it. I want to say just recently we saw the last state kind of close the loop on that. I don't know. I'm not the FDA, but I got to imagine that they had to feel some kind of pressure knowing that all 50 states had done something to regulate this. On May 5th, the FDA said that they would regulate these devices. Some of the concern is, even for people who are buying the constituent parts, is it safe? I'll be honest, Michelle P. standing here today, knowing that people can buy the constituent parts and make their e-liquids, and they'll still have access to their vaping device, their atomizers, whatever generation that is, still going to have some challenges here because you can get the constituent parts. So it'll be interesting to see what happens in the coming year with the regulation. I don't think it's going to change how these devices are being used for illicit purposes. There's lots of blogs, there's lots of conversations, there's lots of videos online that essentially it's folks advocating for how these are great devices to mask vaping methamphetamine at work.
You don't understand here, Michelle, because it seems to me that the systems are very easy. And in some respects, almost too easy. I'm shocked, or maybe I'm just not paying attention, that we have not heard about more overdosing and things like that using these systems and things like methamphetamine.
I don't know that it's hit the media. I know that when we just put on a workshop at the American Academy of Forensic Sciences, and, where I guess for 2 years I've been asking anybody that would listen to me, hey, are you seeing these in your lab? A handful of labs were saying, yeah, but we don't know what to do with them, because it was such a new widget that came into their lab, and it's mostly just connected to nicotine, right? So a lot of labs that I talked to essentially said that they weren't really analyzing them. They weren't doing anything with them. I did talk to a couple of labs who said, yeah, we'll start testing them. And sure enough, of the E-Cigs that they're getting in, quite a few of them do have something illicit in them. When you search around, there are a handful of people that work at labs saying, yeah, these are a problem. Yeah, we are seeing these. So I think at this point it is still an issue of education. One of the values of the grant is to be able to disseminate our findings. I think one of the other things that needs to be underscored here is that much like traditional cigarette smoking, people will regulate, they'll moderate how much they're actually inhaling. so they can kind of calibrate or titrate how much they're actually taking in. We are seeing that the newest generation, the newest thing that we've kind of dabbled with, even though it's outside of the aims of our current grant, is that the newest generation is called a dripper. And so this is probably the scariest. One of the reasons why we think that we're not seeing, just a flood in the media of people overdosing because they're using e-cigs is because if you're going to put drug into that tank that holds 3 milliliters of an e-liquid, right, 3 mils of an e-liquid, that's a lot to dissolve an illegal drug in to get your hit. And so the people aren't probably really going to buy into that or to do that. And so the current method is this dripper method. And so what we're seeing on the drug blogs is, yes, they are doing that. They are putting it in an e-liquid. And there's lots of videos about how to do that and how to best do that. Here's the best practice for this drug if you're going to put it in an e-liquid. And all those videos exist. But the dripper system, the fourth generation of e-cigs that is really gaining a lot of popularity right now, is that there is no tank. You literally just heat your coil up and drop the drug right onto the hot coil. And then, a cloud is produced, and you inhale the cloud through essentially a straw or through the mouthpiece. There are lots of videos of people doing this, of putting wax or dabs, right, that's THC, right onto these, or you put your botanical right onto it. At some point, you kind of cross the boundary because these coils are getting so hot that, well, are we back to combusting our illegal drug because it's not creating this vapor cloud if you're not putting it in the e-liquid? So we're back to kind of this gray area of methods with some of the ways that people are using e-cigarettes kind of beginning to take on. But if we scale back to the traditional e-cigarette that we see people using that looks like this tube that somebody's sucking on, that's got a tank that holds 3 mils of an e-liquid, there's probably some challenges for people to be able to actually vape a drug in that way.
Let's go to your research now. What has your research found? Where are you in terms of what you've been able to discover about how these devices work and deliver and how that can be manifested in toxicological results?
So we're almost finished with building the model in terms of we developed a trap and we developed our analytical methodologies. One of the things that in terms of building the model was, we heard this time and time again, and this was really important for the vapors. They get a battery, a power supply, that allows them to change the voltage on the power supply. What a vapor will say is that the higher the voltage that they can dial in, then the more drug that they're going to get in the cloud. If you're going to say that, then you kind of have to take off of the table considering how much of the cloud people are actually inhaling, right? I mean, it's just like a traditional smoker looking at somebody making major drags on a cigarette or minor drags on a cigarette. What is that puff topography? So if you take that off the table, which complicates the conversation, and just look at, hey, these people are increasing the voltage on their power supply so that they can increase the drug concentration in the cloud, in the vapor. And so we looked at, that was one of the first things that we took a look at. Sure enough, we saw that there is an increase, and this is with nicotine, right? We're building the model with nicotine, is that there is an increase of nicotine in the vapor as you increase the voltage. Is it significant? Well, it's statistically significant, but when you put that really complicated thing called puff topography back on the table, I don't know that it's all that significant. From a functional perspective, we are seeing that, and we're finalizing that manuscript right now to show what that data looks like. Some of the other things that we've actually done, one of the things that vapors can modify is the coil that is getting hot when you hit the power supply button. And so there are a couple of types of metal that are really popular at different gauges, right? It's just a little wire. So we took a look at the two predominant types of wires at, I think, 3 different gauges, and we looked at it across all of the voltages. We looked at 2 different configurations. We call it our burning experiment. So we have probably collected more than 10,000 different temperatures in different configurations, in different variables, to have an understanding of what's happening with the coil. How hot is it getting? It's been a pretty significant effort. It's taken us almost 2 years to complete that, and so we also wanted to look at it in terms of how hot is that coil getting when it's 100% PG, and how hot is the coil getting when it's 100% VG, because the e-liquid makes a difference on how hot that coil is getting. In terms of that temperature profile, only some of the variables are making a big difference. We've got some mythology built in there in terms of what the vapors think is going on, and we have a little bit of reality in there as to what they actually thought was going on. We received a sample from the West Coast that claimed to have THC in it. You know, this whole time we have in our mind, we had essentially gathered up these 27 e-liquids, and when we looked at labeled concentration versus actual concentration, we found that about 30% of the e-liquids that we got here in the United States, about 30% of them were more than 20% off of what they claimed was in the e-liquid. So now we have on our mind this whole issue of quality assurance. So when we received a sample in from the West Coast, and this came out about a month ago in the Journal of Analytical Tox, the vendor claimed that it had 69% THC in it. You know, after we picked our chins off the table, we said, well, how much does it really have? And it still had about 42% THC in it.
That's still impressive.
Yeah. And then we also found quite a few other cannabinoids that were not on the label. So, you know, again, we've got an issue of transparency in products that are on the market and quality assurance in the manufacturer. And so that was just published. So we've discovered those kinds of things in the process of developing our model.
I mean, I guess partly what you're doing is allowing folks to have a basis by which to identify what's coming into their laboratories in some reasonable way. At some point, you're going to want to connect this to toxicology, though. Is that part of your plan to be able to do that?
Yeah, absolutely. So this summer, we've actually already have some preliminary data where we've put methamphetamine into the e-liquid. And wow, that's pretty data. So we're really excited about the preliminary data that we've collected thus far with methamphetamine. So I keep referring to these analytical methodologies that we're using because one of the pieces that we're concerned about for laboratories that receive this kind of evidence is how can they safely analyze? You know, because you hear these awful stories about the batteries exploding. So laboratories, you know, should exercise some caution when analyzing these. And so we're looking at different ways of, hey, can we just take the battery off and put the entire device into a can and do some headspace analysis? Versus if you have the e-liquid, what do you need to find out? Because there are some labs that are actually receiving e-liquid samples in. And so what are some of our best methods to help people take a look at these e-liquids? You know, so far this is a lot about controlled substances and how do you identify it and what is the problem and kind of monitoring the impact of this trend. And we can make some leap to interpreting it from a toxicology perspective.
Stay tuned as Dr. Peace gives you an update on her research.
So that is good information about the methodology that Michelle Peace and the group at VCU have been doing for vaping. Just to remind everybody, we're with Michelle Peace from Virginia Commonwealth University, the new president of the Society of Forensic Toxicology. So, Michelle, you've now been doing your research work under the NIJ grant, and how's it going?
It's great. We've actually had 2 grants with the National Institute of Justice. The first grant was really just to figure out what are these electronic cigarettes, how do they work, how can they be manipulated, and pretty quickly and likely as a result of the industry being largely unregulated here in the United States at the time, there was a pretty rapid evolution of the technology for the electronic cigarettes. And we saw that while we were working on the first grant. So we submitted for a follow-up grant, and we called it Chasing the E-Cigarette Dragon. And part of that one was based on some data that we had gotten out of the first grant. So one of the mythologies about the electronic cigarettes was essentially users were saying, if I put more power on the electronic cigarette, if I increase the voltage, or I change the resistance, then I'm going to get more drug in my aerosol. And when we took a look at, we developed a trapping chamber to trap the vapor and measure the concentration of the drug in the aerosol. And we saw an increase, but it wasn't like it was a significant increase. And we couldn't really figure out if that was really would make a practical difference in terms of the experience that the user would have. So the premise of the second grant was to say, hey, we need to explore this because we're not really seeing, with nicotine as our model, we're not seeing a really significant increase in the dose in the aerosol as the user increases the voltage, which was common at the time. And so the thought was, well, maybe it's changing the particle size of the droplets in the aerosol. And, with smaller droplets in the aerosol, then it could, penetrate into the deeper lung. So we had to figure out how to use, as nicotine as our baseline, how do we now measure the size of the droplets? Those are called particle sizes. How do we measure the size of those droplets in the aerosol? And does that change with the change in voltage?
So one of the things I wanted to ask you here is whether we can generalize from nicotine to controlled substances like marijuana and THC. How much difference would you see with THC or with a THC oil, I assume is more common. Is that right?
Yes, it is.
Do you believe that when they up the power for the nicotine, obviously, as you're saying, that there's not really that much difference, but do you think that would be generalizable to THC and any other drug that might be put in there?
So we've actually been able to pursue that with the second grant.
Good.
Yeah.
You're way ahead of me. That's good, Michelle.
So, what we found out with using nicotine as essentially our baseline, so that we could understand, if we're talking about nicotine, how does that actually compare to a tobacco product, right, a traditional cigarette? So that was the first part of what we were, trying to figure out. And then once we developed this baseline with nicotine, then we said, hey, does it change if we put anything else in there? So we took a look at methamphetamine and methadone. We chose those drugs for really specific reasons. And so some of that is, literally about how big is that molecule, right? Is the size of the molecule itself going to impact how big the droplets are? Some of it is about what is some of the other chemical properties of the drug. Is that going to change the particle size? And so, if we go back to nicotine, what we really discovered is that the particle size is really changing only with, the ratio of the propylene glycol to the vegetable glycerin. And so what was interesting is that the users will say, oh, I get a better hit in my throat if I use one versus the other. And when we saw our particle size data, we're like, well, wouldn't you know it? What we're seeing in the data confirms the actual physiological effect that the user feels. And, so the bigger the droplets are, the more likely they are to hit the back of the throat. So what we saw is that the particles are bigger if they just use 100% propylene glycol. And the users will say, hey, if I use 100% propylene glycol, I get this really strong hit in the back of my throat. And so it was nice to confirm that what the users are experiencing, we're seeing in the data, and why we're seeing that, which up to this point hadn't been the case in any of the other mythology that had seemed to pop up with what the user's experience was.
So what kind of particle size are we talking about? When I think of aerosol particle size, I'm thinking of like in the 1 micron range. Are these particle sizes that small, or where exactly are they in terms of the range?
They're actually pretty similar to what you see with traditional tobacco cigarettes. And so it is, but the mean mass diameter of the particle sizes are around 0.3 microns. And anything down around 0.1 is getting into what's considered the ultra-fine range. So traditional cigarettes are about around a 0.3. So we're seeing that electronic cigarettes are producing particle sizes very similar to what we're seeing with traditional cigarettes.
And that's even true when they use the propylene glycol either in higher concentration or exclusively. They're increasing from 0.3, but they're not going up to like 1 or 10 micron or something like that.
No. They're going to be just slightly bigger. We use this device that breaks it down into sections. And so we're really looking at something that might tend more to be, I want to say, it'd be less than a 1 micron.
So the next thing that raises, Michelle, is so I was driving to work today, and I was following somebody who I know was vaping because I know the difference between smoke and vaping, right? I can smell the smoke very specifically.
Right.
And it was a huge cloud. I'm sure I was getting secondhand vape. I mean, at that point then, you're going to get the same kind of secondhand exposure as you would with a regular cigarette than from a vaping thing. Isn't that correct?
Yeah, there are actually a lot of questions and concerns about secondhand exposure to vaping right now. And some of that is, because it is visible. You see this giant cloud, and people are concerned about inhaling what is in the cloud. I've been consulted on a couple of cases with regards to the secondhand exposure. And unfortunately, right now, the folks who actually study secondhand exposure, whether that's to cigarettes or now it's e-cigarettes, right now the data is pretty conflicted in terms of what exposure you're actually going to get. It seems like the data is turning towards, is very preliminary right now, is that yes, you are going to be inhaling whatever drugs are in the cloud. I hate to speak anecdotally, but as somebody who watches people vape, and you certainly get concerns about secondhand exposure, for folks that are smoking a joint. I mean, that's a real thing, and there's a lot of data to actually support that. And so it might not be that far of a reach for us to all have some tremendous concerns about secondhand exposure with e-cigarettes.
Yeah. Is there any chemical breakdown during the vaping process of the parent drugs? Do we have any information about that?
Right now, very little. We've tried to take a look at, particularly when we were looking at methamphetamine in the e-cigarettes, we were looking for natural breakdown products of that, particularly amphetamine. And we didn't see that with methamphetamine, which is a really small molecule. So with the parent compound itself, we think not. And some of that is because we think that the aerosolization is happening so quickly and that, the drug conceivably is pretty stable, even though that coil is really hot. So we think that probably the drug itself is remaining intact and the drug itself isn't degrading. But the studies around that are not very robust yet. Our big concern really about degradation is with regards to propylene glycol and the vegetable glycerin, of course, breaking down. What are some of the other chemicals that are being broken down that's actually in the mix as well, whether that's part of the flavor profile. There's a very complex flavor profile for a lot of these e-liquids. The e-liquids also have ethanol in them, and so we have a lot of concern about people vaping ethanol. And one of the other things that has really came off of the back end of our first grant, we started taking a look at the coils. And the first part of our project was really, a lot of people, you heard like these murmurs around, are we vaping metals, are we vaping metals? So, well, we don't know. So let's just look at the coils under standard vaping conditions, and let's take a look at them under the scanning electron microscope. We were shocked by the pictures, which really made us backpedal and say, wow, we've got to see what metals are disappearing off of the coil.
So the coils were breaking down. You were seeing maybe some kind of hydrogen embrittlement or something along that line on the coil? Some sort of,
you can definitely see where a new coil might look relatively smooth, and then our first studies were to really stress it, just to see, right? So let's run it through a series of burns, just like a normal vapor would do. Let's hit the coil as many times as a normal vapor would, and let's see what the coil looks like at the end of that. Wow, it's pitted, it's cracked, there's significant damage to the coil. So then we said, well, let's back off of this and see, well, when does all of that damage occur? Does the damage occur after the very first time you light up that coil, or is it over a period of time? And wouldn't you know it, we actually saw really dramatic change in the coil after the first light of that coil, of a brand new coil. We then looked at SEM EDX, so we said, all right, well, what metals are disappearing? And it depends on which coil type you're looking at, but we definitely saw a decrease in some of the metals that should really cause us some deep concern. So now the question for us is, well, are those metals that are coming off of the coil, are they actually in the aerosol? Or, right, because you think about it, they're coming through what is conceivably a cool mouthpiece. The mouthpiece of an e-cigarette is metal and it's cooler. And so we thought, well, maybe there's enough condensation and metal is heavy. Maybe the metal is accumulating on the inside of the mouthpiece to the electronic cigarette. We're wrapping up our studies right now, and definitely the metal is in the aerosol and not in the mouthpiece, yeah.
What are the coils generally made out of?
Yeah, so the two major coils that are being used now, one is called nichrome, and it's predominantly nickel, but it also has iron in it, and it also has chromium, so nichrome. The other major coil that is used is called a canthal wire, and that's actually has a broader composite. So, of course, it's got iron and chromium in it, but it also has silica, manganese, and aluminum in it. So the users select one or the other wire depending on what they want their own experience to be, because the canthal wire, because it's got more kinds of metal in it, it has a higher temperature tolerance. So for vapors who want to vape at higher temperatures, they'll choose the canthal over the nichrome. Interestingly enough, even though the nichrome wire operates at a lower temperature, that seems to be the one that is of preference for users. So we took a look at, what is actually disappearing off of these coils, and of course we're seeing a lot of iron come off of these, and chromium is coming off of the coils as well, and certainly a couple of metals that you don't want to be inhaling.
Sure. I assume they must be complexing in some unusual way with the organics in the vaping mixes and somehow being transported in that way. But of course, it's way too preliminary to be able to speculate about that.
Yeah, it is. At this point, we're collecting samples right now, and we're running them by ICP-MS, just so that we can get some kind of number around how much is somebody actually inhaling when they're vaping, just so we can get some idea about that, and then we'll see where that takes us, and whether or not we want to take up that mantle.
It goes back to this original discussion, more power, right? So I can get the more drugs into my system. And talking to people who do this with nicotine, either because they're trying to quit or just because they like it, they often say that the level of nicotine that they get, or at least their feeling is what they get from vaping, is smaller or less than what they get from a regular cigarette. And so it seems like they're always kind of chasing a little bit, how to fine-tune it in order to get something that's more similar to the cigarette experience.
There are a lot of really great studies going on. Some of them are right here at VCU, where they're studying people's behavior around the electronic cigarette, particularly for those who might want to be using it as e-cigarettes as a step down from a traditional cigarette, right, towards cessation. I think a lot of people are really kind of getting away from how much do I have to have in the e-cigarette to be equivalent to what I get in a traditional cigarette? And some of that might be because there's just a different culture around vaping than what there seems to be around a traditional cigarette. And so, right, where people will literally moderate, it's like the traditional cigarette. They moderate how much they actually want. So if they begin to feel like they're getting too much nicotine, then they'll back off of it. But there's, much like any kind of drug use or drug abuse, whichever camp we happen to be in, the user is going to modify how they take the drug depending on the device. And so making some kind of correlation anymore to how it compares to a traditional cigarette is, I think what the community is deciding is it's a different beast.
It really raises a lot of questions, especially when you're talking about something like methamphetamine, which of course is also often smoked and is very convenient in a vaping kind of framework. Some of the nastiest effects of methamphetamine are pretty fundamental. I'm not sure it matters whether you smoke or vape, but there might certainly be some perception difference between the two.
Yeah, agreed. I think part of the perception is going to be really for people who are going to choose to vape methamphetamine in a clandestine fashion, right? So we have literally seen so this is some of the concern around secondhand vaping, whether it's methamphetamine or THC. There's certainly a lot of concern about this, right? And so you've got people who are concentrating out on their smoke break, and vaping these, giant clouds, and you may not necessarily know that all they're vaping is nicotine. There seems to be a pretty strong user population that doesn't have any concern about putting other drugs into their e-liquid. So that was actually some of what we chased on the second grant, was the evolution of the electronic cigarette, because we've gotten accustomed to seeing, people use electronic cigarettes that have this reservoir in which they put their e-liquid. And then there was some concern about, well, are they putting enough drug into that e-liquid to just vape it all day, or are they now going to just drop whatever their drug of choice is that might not be nicotine right onto the coils and vape directly from there? If you are now using a device called a dripper, you can just take that e-liquid with the botanical material in the e-liquid and drip it right onto the coils and use a specialized mouthpiece or a straw just to inhale the vapors right off of the coils. And then we saw another generation of e-cigarettes that are really specific for waxes. And so we know that there are drug products out there that are waxes and dabs. And these are like literally just little ceramic cups that get hot, and you can just put a little bit of your wax or your dab in there and put the mouthpiece back on, and now you've got a cup that is holding your wax or your dab, and it's an electronic cigarette. It otherwise functions the same way.
Yeah. So is your NIJ grant continuing, and what else are you looking to do now as you move forward?
Yeah, so we're in the wrap-up stages, of looking at the particle size for methamphetamine and for methadone. Not surprisingly for us, a really heavy molecule like methadone, we saw a really inconsistent dosage in the aerosol. And that wasn't surprising to us. We've found there's plenty in the literature around, the fact that it can be really difficult to aerosolize an opioid. And so there's literature out there, and certainly in the user community where they recommend, hey, why don't you cut your opioid, wherever that is, with caffeine. And so the next thing that we're actually going to do, because while the research is certainly about how are e-cigarettes being evolved for nefarious purposes. It is the National Institute of Justice. So,
yes,
so
we do care about crime, yeah.
Right. So, but one of the things that I always think about is if we can figure out how to leverage electronic cigarettes and that device for reasonable, good, therapeutic, pharmaceutical purposes, this is a technology that could be actually quite valuable. So it's one of the reasons why I chose methadone. Our next stage is, because it has such an inconsistent aerosolization, the dosage is pretty inconsistent, we're going to try to improve that. And how do you do that? And some of that is, we'll cut it with caffeine, and we'll change a handful of other parameters to see if we can actually improve the dosage in the aerosol. We're going to work on that. Right now I'm writing my next NIJ grant. We have spoken with a number of e-cigarette shops, vendors. We're constantly monitoring new products online, and we're seeing a slowing of the evolution of the products. So we'll continue to keep an eye on products, but we think that we might have peaked at the evolution of it. One of the things that chiefly concerns me now is that e-liquids have ethanol in them. Let me just say, I have a lot of concerns about people who are vaping ethanol. We have seen some of the products that we have here in our lab. We took a look at the ethanol concentration in those, and it is upwards of 20% ethanol. We've seen in the literature where there are some laboratories who are reporting seeing e-liquids that are as much as 23 and 25% ethanol. So if you're vaping that ethanol, honestly, and this is why we're writing the grant proposal, is vaping ethanol in the concentrations that are in those e-liquids might not be enough to put you over the legal limit for alcohol, BAC 0.08. But certainly my concern is if somebody were a .07 or a .06, is vaping an e-liquid that is 25% ethanol enough to put you over a .08? And so we don't know that. And so, whether that winds up being positive in terms of it does push you over, or it's negative in terms of no, it doesn't push you over a .08, I think for the forensic toxicologists who are having to testify as to particularly the impact of vaping, then I think it's important for it to at least be in the literature that, hey, somebody has taken a look at this, and either it does or it does not impact the BAC. So that's what we're going to be writing our next, we're in the process of writing our proposal for that now, anticipating the next release for the RFP.
It's really amazing how many research questions this raises, because we really haven't even touched on how this might affect toxicology to a very large degree. We really don't understand, whether this would impact on differences in urine or oral fluid or hair testing and things of that nature. It's an open book,
Absolutely.
isn't it?
Yeah, absolutely correct. Somebody has told me about a year ago that I could probably spend the rest of my career just chasing this. The general public is also pretty clever. So the question is always going to be, how is this going to continue to evolve? So there's always going to be some work to do.
I think there's always been kind of a technological arms race between the research community and the law enforcement community on the one end, and those who are trying to find new and interesting ways to deliver drugs of abuse of various sorts. I honestly think the arms race has accelerated here in the last few years between the issues with fentanyl and now with vaping and the emerging synthetic cannabinoids and things of that nature. It's just extraordinary how much change there's been.
Yeah, it's terrifying, right? That we've never really been able to keep our arms around the problem. And so the question always becomes, well, what kind of resources are we going to actually get to combat this? And of course, as the problem has grown, our resources to combat it has not also grown at the same rate. And so it really does create this call to arms at all levels to say, how are we going to do that? And certainly one of the things that I think about is how can a forensic toxicologist, what is our role in helping to combat all of that as well? And, so from a career perspective, it's an exciting time, right, because, we're always seeking to protect public health and public safety, but at the heart of that task is something that is actually really terrifying for us. So.
Sure. Well, just so you know, since you are the new president of SOFT and you are chasing the E-Cig dragon, we're all just following your lead. You're going to be in charge. We'll just go wherever you say. Well, thank you for being with us on the Just Science podcast, Michelle. This is excellent information. Obviously, there's a lot more to come, and I hope we'll be able to have you back onto the podcast and learn more about the next things that you learn about vaping.
I am always happy to talk about this. Always happy to be, a part of what y'all are doing, because I think these podcasts are actually pretty extraordinary in terms of really informing the public as to, what are our concerns, and you've got a bunch of really good, smart people who are working on some of our problems, and that should generally, hopefully makes people feel at least a little bit better that, hey, somebody's working on this problem.
Thank you, Michelle.
No, thank you. I appreciate the time.
Next week, Just Science talks with Dr. Jerry Rapero-Miller and Dr. Gary Zarkin about what can and is being done to combat the opioid crisis. Opinions or points expressed in this podcast represent a consensus of the authors and do not necessarily represent the official position or policies of its funding.